In this video, we are going to see solving first order partial differential equation of standard type 3. Okay, so here in the standard type 3, it is the function involving x, p and q alone. So the equation will be function of x, p, q is equal to 0. So the first question is solve p is equal to 2qx. So in this type, first we have to assume q is equal to a. So always whenever we have a function only xpq alone, we have to first step is we have to assume q is equal to a in the given equation. So let us take the first equation as p is equal to 2qx. In this we have to put q is equal to a, which gives you p is equal to 2a into x. And also we know that z is a function of x and y. We can write dz is equal to dou z by dou x into dx plus dou z by dou y into dy, which can also be written as p using the usual notation plus this is q into dy. So we can have dz is equal to p dx plus q dy. So now already we have assumed q is equal to a, which gives you p is equal to 2ax. Now we can use it here. So dz is equal to, this is 2ax into dx plus again q is assumed as a. So we can write a into dy. Now integrating this, we obtain z is equal to 2a into, this is x square by 2 plus here a into y plus one arbitrary constant c. So here we can cancel this 2. So finally we can have z equal to ax square plus ay plus c. So which is the relation having two arbitrary constants a and c. So this is called as complete integral. Next is to find the singular integral. To find the singular integral, let us consider the complementary function, which is equal to ax square plus ay plus c. Now to find the singular integral, we have to differentiate partially with respect to c. So while differentiating partially with respect to c, we have 0 is equal to 1, so which is an absurd result. So we can conclude that there exists no singular integral. Next is the general integral. So for general integral, already we have to consider the arbitrary constant c as a function of another arbitrary constant f of a, and then we have to differentiate partially with respect to a, and then by eliminating a we obtained the general integral. So this is by usual technique we can find out. Now moving to the second question, root p plus root q is equal to root x. Let us assume q is equal to a, so that root p plus root a is equal to root x, or otherwise root p is equal to root x minus root a. Now to remove the square root, squaring on both the sides, we have p is equal to root x minus root a the whole square. So opening the bracket, it gives you x plus a, because root x whole square is x, plus root a whole square is a, minus 2 times of root a into root x. Now already we know that dz is equal to p dx plus q dy, which implies this is equal to p is x plus a minus 2 root a root x into dx plus q is a into dy. So integrating on both the sides, we get z equal to integration of x is x square by 2. Here a is constant, so ax minus 2 root a into integration of x to the power 1 by 2 is x to the power 3 by 2 divided by 3 by 2, plus here a into y plus some arbitrary constant c. So this gives you the complete integral. Okay, next is to find out the singular integral. So while finding the singular integral, that is, I have to differentiate partially with respect to c. While differentiating it, we have 0 is equal to 1, which is an absurd result, so that no singular integral. And then again, we can find out the general integral as usual by substituting c is equal to f of a. So
That's it for today's session. Thank you for watching.